when you have to go for a dynamic analysis method. So linear dynamic analysis shall be performed to obtain design lateral force systems, design seismic base shear and distribution of different seismic level along height of the building to various lateral load resisting elements. So what is the purpose is to get the base shear and what are the force which is distributed to each floor. If you are constructing 10 number of stories, what is your lowest story, that is ground story, what is the base shear which is occurring there, and what is the shear which is being transferred to each and every floor. This is the reason why you are doing this analysis. Okay. For buildings other than regular building lower than 15 meter in seismic zone 2. If you are having a regular building, you can use equivalent static load method. If your building is not regular, you have to use dynamic analysis method. The analytical model for dynamic analysis of building usually configuration should be such that adequately represent irregularities present in the building configuration. This class identifies that when you are designing by this kind of software, how well we model our structure. Currently, we have not considered certain things. What are they? They are the walls, which are not considered. Walls are not only partition. During any lateral load, the masonry walls acts as a diagonal force resisting member and it provides the additional stiffness, so which we have not considered here. So this should also be considered here when we are doing dynamic analysis. How well we are doing the analytical model for a dynamic study, which is very much important. And as of now, we are doing equivalent static load method. We have not considered the stiffness of the brickwork, but you are taking it rigorously. You have to take all the parameters which are acting in a structure, which should actually resemble your structure practically. So all the components should be taken and it should be analyzed. If any irregularities present in the building configuration, then you have to go for a dynamic analysis. Our building also have some stiffness irregularity. So you have stiffness difference between the two story. So this is one of the irregularity. The irregularity might be in stiffness, or it might be in mass, or it might be in damping. So these are all the irregularities which are present in the building, which has to be modeled properly before doing the dynamic analysis. Yes, these are your diaphragms. So this is what I would like to highlight now. Torsion. When you will be having a torsionist, the provision of torsion shall be in all the buildings, increasing the shear force and lateral force resisting system element, resulting twisting of the building about the vertical axis of building arising due to eccentricity between center of mass and center of resistance of the floor. This is the part where you are having center of mass and all the forces will be acting in the floor. At joint wise, you will be having all the forces. So if you combine, you will be having the center of resistance. If center of force and center of resistance coincides each other, then you will be not having any torsion. If this is your mass center and your earthquake force is acting in some other direction, you will be having some eccentricity. So this eccentricity creates the torsion in the axis. So at each and every floor, you will be having different center of mass and center of resistance. So these two are different. You will be having torsional effect due to external force. So the external force is not going to coincide with this. The mass center will be one side and center of resistance will be at another side. So due to seismic force, you will be having different number of effect due to that. Okay, this effect is termed to be as torsional effect. How to design for torsional eccentricity is 1.5 times ESI, static eccentricity, and B is the base floor. So you can find the eccentricity is the difference between these two, center of mass and resistance. So if you need to find that, it is available in the analysis result. So when we are During the next session, we will discuss in detail. Static eccentricity is the distance between center of mass and center of resistance of the floor. So you can calculate either by this method or by this method. So this is designed for eccentricity and SI. SI can be found out by using this technique. Static eccentricity is the difference between center of mass and resistance of floor. Also, you can find BI is the floor plan dimension of floor in I. If you are finding for each and every floor, you will be having these difference. So this is what I said. The mass will be at one side and both the mass will be at different side. For each and every floor, you will be having the eccentricity. This creates a different torsion at levels of the story. Okay. Diaphragm which transmits the lateral force to the vertical element connected to it. So in this problem, this is a diaphragm and each and every column which is taken as a stiffness. What is the purpose of diaphragm is to transfer the lateral force to the vertical elements connected to it. So whatever forces which is acting in this column below, which will be transferred through this diaphragm to the rest of the column. This is the purpose of making into a singular element. So before making any analysis by equivalent static method or dynamic analysis or even earthquake analysis, make all the floor as a diaphragm. Next parameter, the story drift limitation. In no area the story drift shall not exceed 0.004 times the height of the structure. If you are having 3 meter height for a single structure and next level is 3 meter. So totally 6 meter is your height. So you can calculate it. So 6 into 0.004. If you multiply that, you will be getting 0.024, which will be your maximum drift limit. So this is what the first story or the second story should not drift beyond this. Okay, number of modes to be considered. How many number of modes? You can find the number of modes here. You have to define modal loads, modal cases. If you are wanting to modify the load case or modify the model, you can do modal analysis. So you can see here there is a modal factor which is given here, P delta analysis, which we are not doing. There are two different types of analyzing. Which one is eigenvalue and Ritz method. Here we will be using Ritz method and P delta analysis we will be taking as nil. Why? Because this analysis will be very much predominant in when your structure is too much tall. If your structure is tall, then P delta analysis plays an important role here. And number of modes to be considered is 6. Here we have considered 6 number of modes. For each and every floor, you will be having X direction and Y direction as the two modes. Why? Because earthquake is acting in X and Y direction. Also, the moment can occur, which will occur at the Z axis. So, hence it is taken as 3 number of acceleration as our mode. And for a story, we will be taking 3 number of modes, and hence for 2 story, let us take 6 number of modes. And the minimum number of mode is 1. Frequency shift we have taken as 0, this as 0, and convergent tolerance. So during the iteration, how to converge it, it will be taking into 1 into e power minus 9. So it is very much enough and we will get accurate answer for this. So this is called eigenvalues. In the code book, it is indicated that number of modes to be considered here is it should at least match the sum of modal masses, and these modes should be 90% of total seismic mass. As of now, we have considered 6 number of modes, and if we press OK, when we are doing the analysis, so let me show here. Let us run analysis. After completing the analysis, you will be getting the report. So in report, you can check the parameters, and in table you can check while analyzing. These are the model information. The model mass participation factor. If you can see that, yes, the time period of first mode is 0.208 and time period of second natural frequency is 0.118, mode shape 3 is 0.15, 0.107, 0.103. You can see that slowly it is reducing to 0, and these are the fundamental natural period. Okay, and these are the displacement of mass, which is 0.599, and in y direction it is 0.0041. When it is moving in first natural mode, this is the case. When it is going in second natural mode, which is in y direction, this is your total displacement. Okay, if we are taking this, we can look into the summation of all the displacement in x and y direction, how much it is displacing in x and y direction due to the force. Now let us look into mass participation ratio. You can see that more than 90% of mass participation is being achieved here. In static, 100% of mass is being participated, and in dynamic, 98.77% of mass participation ratio is achieved. So number of modes whatever we have taken is okay to conclude. Okay. Regarding the vertical effect of earthquake, why we have only considered x direction and y direction? What about z? When an earthquake is occurring, does the building move up and down? This you will be having a question. So when you should consider the vertical earthquake effect is, the code suggests that effect due to vertical shaking shall not be when the following consideration. If you are constructing in zone 4 and zone 5, you have to consider vertical effect. You have to consider ux, uy, also uz. The structure has vertical plan irregularities. Example, this structure. Our structure is having vertical plan irregularities. The first floor and second floor is not similar. So we can calculate Z, that is vertical shaking of our structure. The structure is rested on soft soil, hence this is a rock soil where we are considering is in Bangalore area, hence it is not required. In bridges, long span, structure has horizontal overhangs of structural member or subsystem. If you are having long balconies, projected lines, and roof, if you are projecting at one end, you will be having vertical earthquake effect. When you are considering the vertical earthquake effect, the code suggests that you should add the Z axis also. In previous cases, you can see 1.2 dead load, live load. In these cases, you can note that Z axis is also considered now. Point 3 times EL Z. So what is the predominant mode of action of force? At the rest of the directions, you have to take 0.3 of the forces. So these things will be calculated automatically. In manual, you can find vertical acceleration by using this formula. Let us discuss response spectrum analysis. Okay. Before going to that, let us understand what is modal analysis. Okay. In dynamic analysis, a structure is considered to be as a model. In static analysis, it is different, but in case of here, you will be considering all the masses as a M. It might be the mass due to slab dead weight, and it might be due to wall load or live load. All the masses are considered as a weight, as a single weight in the floor. Whatever might be your dimension of your hall, it is taken as a single mass. And next thing is column. Column is not a load carrying member in case of dynamic analysis. It is a stiffness member. Column self weight will be ignored here and only stiffness property of the column is taken. When you are doing with static analysis, you will be dealing with Young's modulus. Modulus of elasticity is the major factor. But in terms of dynamic analysis, the stiffness is very much important for a column and damping ratio. Third thing is damping component. The damping is if any object is oscillating, it will definitely come to rest at one point of time. 5 types of damping are available. So as of now, in this problem, we will be considering dampness as 0.05, that is 5% of damping. All the structure are considered as 5%. You can increase the damping. If dampness increases, the structural response decreases. That is, if your building is going to deflect 20 mm, assume that. If your structure dampness is 20%, total deformation is going to get reduced by 16 mm or 15 mm like that. If your dampness is 5%, it will be reducing 20 mm to 18 mm. So your total displacement depends on dampness. If higher the damping, the lower will be the displacement and oscillation period. It will be having less oscillation period. Imagine you are switching off your fan. The fan should stop rotating. But what happens? The fan will keep on rotating for some period of time and it comes to rest. Why? Because this time which is taken by the fan to come to rest is known as damping. If damping is not there, if 0% damping is there, even if you switch off the fan, it will not get switched off, it will be continuously rotating forever. This is 0% damping. Practically 5% of damping is assumed. If you are having higher damping, the fan will get stopped as soon as possible. So these 3 parameters are important for dynamic analysis. Mass factor, stiffness factor and dampness factor. So these 3 will be taken in terms of modal analysis. So modal analysis is used to determine vibration modes. How many modes of vibration are there? If you are having a single story, every object will be having three dimension of vibration. So let me show this example. Yes, if you are having any object like this, take this as a single floor and you are here in a first story. Imagine all the floor is being taken as a single load and single mass. Let us take here. Imagine that this is a single mass. All the floors are as a single mass. You only have 2 masses. You are having this floor, you have made it into diaphragm, a concentrated place where you are having center of mass. So you are having only 2 mass here. Okay. Stiffness, all the column will be taken as a stiffness member. It is going to automatically calculate it. Okay, let us come to the problem. Yes, modal analysis is used to find the modes. If you are having a single mass, you will be having how many modes of deflection available? This object can deflect in x direction or it can deflect in y direction. It can deflect in z direction. There are 3 possibilities. It can rotate in y axis, x axis and z axis. For a single mode, in a 3-dimensional case, you are having 6 possible number of rotations. So if you are having 2 masses, these 2 mass can be rotated to 6 into 2, which is 12. So 12 number of modes are possible. Now we are considering only one force at a time. That is, we are applying only force at x direction and force at y direction. So we are finding it separately. Hence, 3 number of modes are enough. 3 plus 3 will be 6. So that is why in modal analysis here you can see that in define, in modal case, we have applied only 6 number of modes. Here you can see 6 number of modes we have applied. Ux, if the ground is displacing in x, if it is displacing in y, and z is rotation, r is rotation in z axis. We have taken these three, and 6 number of modes we have taken. This is sufficient for making the calculation. So right now what is identified here and what is highlighted here is determination of vibration modes. So this structure is going to be analyzed in 6 number of modes of vibration. So the modal superposition is basis of this will be response spectrum and modal time history analysis case. This is what I said. You are having two techniques. One is Ritz vector and eigen analysis. Eigen analysis determines the undamped free vibration modes and frequencies of. So if you are doing eigenvector, you can find free vibrational mode shape and frequencies of the system. And if you are doing Ritz vector, to find the modes at a particular loading. So according to what load you are going to find that. So let me show here. You are having two methods. One is Ritz and another one is eigen method. So these two methods are available here, and you will be using either of them. So currently we will be using eigen methods only. So we have done this modal analysis for eigenvectors. Now okay, let us press OK here. Now we have already done the modal analysis. Now let us do the response spectrum. Okay, first you should understand what do you mean by response spectrum analysis. Is it required to do equivalent static analysis and response spectrum analysis? If you are asking, you have to identify either the structure is more than 15-meter height or either it is having irregularity. You have to check that and you have to find. Even though you can analyze a single structure by using equivalent static method and response spectrum method also. For a single building, you can analyze by using both the techniques. There is no issue. Why? Because software is going to do that, which will give you a better clarity on what method you can use for a structure. So generally, what do you mean by response spectrum is determination of likely response of a structure to seismic loading. In short, what do you mean by response spectrum analysis is determination of likely response of a structure due to seismic loading. Okay, what do you mean by that? If your structure is vibrating, if the first floor gets resonance, if the first floor frequency matches with the earthquake frequency, now the first floor is going to get highly vibrated. And if your second floor, which is having a fundamental period, and when it matches with earthquake, this second floor is going to oscillate highly. Okay, if you want to find each and every floor natural frequency, and you will be finding that for each and every floor, determination of likely response of a structure due to seismic loading. If you have 10 number of floors, you will be finding 10 number of natural frequencies for each and every story. So in definition, it is given that it is a representation of maximum response of spectrum. What do you mean by spectrum is, take each and every individual floor as a spectrum of idealized single degree of freedom system. Here, note that this structure is free to move in three directions: 1, x, y and z. Now in response spectrum analysis, it will be taking a single direction where the earthquake is going to occur, which is taken as idealized as single degree of freedom system of natural period. So what are the natural period for each and every floor, which will be identified, but having the same damping under the action of earthquake motion at their bases. If the earthquake is occurring at the base, you will be having 10 floors, you will be having 10 number of mode shapes in a single degree of freedom. Okay, if that is the case, it will check for each and every floor. For each and every floor, you will be having a time period. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Imagine that you have a 16 number of floors. For each and every floor, you will be having a fundamental natural period. if you are getting that fundamental natural period and the spectral acceleration, you can draw this for each and every fundamental natural period. You can connect the lines and you can get the pseudo acceleration response. So for each and every floor, you will be getting the peak of the displacement. Each floor will get the peak of the displacement. You can find it by using this technique. This is called response spectrum analysis. For doing this response spectrum analysis, you don't need to take x and y direction. In equivalent static method, you have done in x-axis, also in y-axis. But in response spectrum method, it will automatically calculate in which direction you will be having the maximum response along the direction of force. So it is going to make the combinations. Okay, let us start doing the response spectrum analysis here. First, you have to define and function. You will be having a response spectrum and time history. Both the techniques are available here. If you go to response spectrum, you have to use Indian Standard Code IS 1893. Add new function. In this function, let us write it as response spectrum analysis. Response spectrum. Response spectrum. Let me like this. And our seismic zone is 2. You know that. And importance factor is 1.2. Response reduction factor is 3. You can see that the graph is keep on modifying. And your soil type. For these conditions, in code book, you have given the rest of the data. So these are the response spectrum which is available in 1893. And at this response spectrum, you have list of natural period for each type of soil. Our soil is first type, rock or hard soil. So this is our first graph. There is a difference between equivalent static load and response spectrum. Here you can see that you will be having a slope, but in equivalent static you will be having a flat point. Okay. When considering this, you can see automatically this function graph is being generated. Note that all the dimensions are in mm square. Whatever units we have given, it will be in the similar units. So let me show it. For this specific case, the graph will be drawn. If you are having at zone 5, you can see that this graph will automatically get changed to 180. This is the time period and this is the pseudo acceleration. If you are having in zone 2, you can see that this will automatically generate the graph by taking the code book values. All the values are available here and this value is given for 5% damping. So 5 divided by 100 will be 0.05. Let us generate this response spectrum and you can see that a function is being introduced. And press OK. Now you can define, let us add a load pattern, make it as response spectrum, and type of load is seismic. Let us take it as 1893-2016. Take it as response spectrum. Add new load. We are adding to the existing load. Let us press OK. Now go to load cases. You can see a new load case is being assigned here. Let us modify this load case. Response spectrum. Now your load case type should be response spectrum. Then it automatically generates the calculation. You should add the loading type. Either do you want to load the ground. The earthquake force can be applied in two methods. One is vibrating the ground or you can vibrate the structure by using any load. Currently, you will be vibrating the structure from the ground. So hence you can take it as acceleration u1. What is your function? Response spectrum. This you can see when we are assigning the function, you had two numbers. We have introduced the response spectrum and we are doing that. Scale factor which will be given automatically, and then add again. One will be x direction and another one will be y direction. The function will be response spectrum. If you need to make in another direction, that is z direction, you can introduce it, or else you can take rotation. You can take rotational force also. You can introduce the response spectrum. Now you have got all the possible modes of vibration in x direction and in y direction rotation. And model case will be, this is model which we have already made the model. Quadratic combinations, you are having different types of combinations, so you can use that. So as of now I will discuss quadratic combination. Now SRSS method, absolute method, and CQC3 method, three types of directional combination types are available. So we will be using SRSS method. So this is mostly used modal damping. We will be using constant damping, which is 5% of damping. If you are doing research and if you are doing different types of damping, viscous damping, frictional damping, structural, passive damping, active damping, a number of dampers are available. Under the research point of view, you can do it. As of now, we are not going to discuss in detail. So let us give 5% damping, and diaphragm eccentricity will be, you will be taking 0.05 times eccentricity. If the force and your center of mass and center of resistance is not coinciding, you will be taking response spectrum analysis, which is applied with an eccentricity of 5%. Let us take it as OK, and it will be assuming that all the diaphragms, if you have two number of diaphragm, it will be taken as 0.05 times the eccentricity. Okay, these are our load case data. Now you can see that rest of the things are all linear static analysis. Response spectrum analysis we are doing by Indian Standard Code, and we have written it as response spectrum, and press OK. Now let us go to load combination. Load combinations. Now we have already made this combinations, and if you check that, we will be having 0.9 times dead load, live load, all the combinations we have done it earlier. We have to just add rest of the three combinations. Okay. Add default design combinations. Let us add concrete frame design and user, convert to user combination editable, and press OK. It will again generate some list of combinations. Whatever is not required, so let us eliminate that. You can see that this is 1.5 times dead and 1.5 times super dead. This we have calculated again. This is 1.5 times dead and 1.5 times super dead. So these loads are already considered. So if it is again taken, you can delete that combo. Okay, whatever is new, let us see that. You can see combination 28 is 0.9 times dead and 0.9 times super dead and 1.5 times earthquake at Y. And 29 you can see same thing, and 30th you can see 1.2 times response spectra. This is the new additional combination, and 1.5 times response spectra, and last three are 1.5 times response spectral analysis. So let us take these three combinations alone. 0.9 times dead load, 0.9 times super dead load, earthquake at X and Y. These combinations we have already considered. Delete, delete, delete. These three are the new combinations. Now here you can see that this is dead load, live load, super dead load and response spectra. Response spectra into 1.2, and now this is dead load, live load, dead load, super dead load and response spectra. Response spectra into 1.5. Now let us press OK, and final load is 0.9 times dead load, 0.9 times live load, 0.9 times super dead load and the response spectra 1.5 times response spectra. This is the last load combinations. Now we got the list of combinations. These three are the response spectral analysis, which is going to be done new. Rest of the analysis we have done in previous session. Okay. Now press OK here and let us go to analyze and do run analysis. Yes, the analysis is over now. Let us check a new parameter now. Let us press display here and you can do story response spectrum plot. And after analysis you can see that due to dead load, this is due to dead load, the maximum displacement is minus 0.48 in y direction and minimum and maximum displacement is visible here. Now if you change to live load and rest of the loads, you can see the difference. We are only interested in maximum and minimum. Okay, you can see here that this is modal displacement and we can take all the load combinations are available. For response spectra, we can check the displacement, maximum story displacement. You can see X is blue color and Y is red color. So what is the X direction and Y direction? The structure is displacing to 0.9 mm. You can see 0.96 and this is 1.08. This structure is displacing in X axis more than the Y axis. So Y axis is having less displacement, which is 0.75 around, and in Y axis the first floor is being displaced to this difference and second floor is being displaced to this distance. Let us see the rest of the things. Auto, what is the force which is acting in the structure is in first story. You can see the force which is earthquake force, which is created around 13.8 kilonewton and the second floor carries 16.4 something, 16 plus kilonewton of force which is acting in X direction. And these are the auto lateral force in the story. Let us look into response spectrum. This is the center of mass, CM displacement, where the mass is being displaced. See, I have already shown you that diaphragm and where it is located. So the diaphragm is deviating from the original point to 240 into 10 power minus 3 mm. So diaphragm is not displacing much, you are having 0.24, and the maximum at the top story is 0.72. Story drift, you can see, story drift is the maximum story drift which is happening at x-axis 200 into 10 power minus 6. So this is your answer, which will be 0.0002. Now earlier we have calculated. This is the maximum deviation which can occur according to code. So story drift limitation. The story drift limitation shall not exceed 0.004 times the story height. Now our story height is, first story is 3 meter height and second story is 3. So totally 6 meter height. So if we multiply 6 into 0.004, we will be getting 0.024. That is 24 into 10 power minus 3, which is your answer. Now if you check to story displacement, you can see that you are having 0.002, which is acceptable. So your floor displacement are not above the limit which is given, and you can proceed with this design. Maximum story displacement, which I have said that story shear. Let us check the story shear. Yes, the base shear in x direction is 21 around, and at y direction is 22. Overturning moment, you can see 0 overturning moment at the top story, and at the base you are having around 100 kilonewton meter. There is a high amount of moment which is there in the second floor. Since you are having a floor which is not symmetrical in mass, so you are having a higher overturning moment at the second floor. The first floor is having around 36 kilonewton meter, and second floor is nearly 3 times. Why this 3 times? Why? Because the mass is not distributed in first and second floor. Next, story stiffness, you can see the answer. Stiffness of each story. First story is having higher stiffness and second story is being reduced. Further, if you increase the story stiffness is going to get reduced. This is for response spectral case. You can check for earthquake in y direction. You can only see y is red color. You can see only red color values. And you can check what is the maximum case, that is response spectral case. Let us check that. Yes, we are having response spectral case. Dead load, live load, super dead load, and response spectra for 1.25 times. Maximum story displacement, you can see 1.35 mm of displacement is occurring at the floor, the second floor. Like that, you can check the combinations. For all the combinations, you can check the values. Here you can see dead load, super dead load plus earthquake in x direction. You can see a displacement of 2.25. Okay, like that we can get the analysis report. Let us check for response spectra. Apply, start animation. Yes. This is the predominant mode, that is maximum mode of vibration. If I am applying in x direction, the structure is going to get displaced in x. See, this is the x direction. And if I am applying in y direction, I can check that and start animation. It is going to deflect in y direction. If I will be giving in response spectra, this is the y direction displacement. You can check absolute maximum, maximum or minimum. If you are checking the response spectra, it will neither go in x direction or y direction. It takes the combination of ways in order to get the ultimate earthquake response. So that is why the deflection is not in either in x or in y, it is in the principal direction of force. This is your response spectra. Let us see the bending moment. For all the load case, we can check the bending moment. For response spectra, let us check the moment. Yes, this is the ultimate moment which is occurring at each and every direction. If you need any detail, you can right click here and you can see the response spectral deviations. This is equivalent lateral load. At each and every point you can see moment, deflection. The maximum deflection is at 1 meter and 0.0032. So the maximum moment which is given at 0.15, it is 1.7. If you change the distance, if you need absolute values, you can check it here. So this is the absolute value, this is minimum value, relative minimum. So like that you can keep on change the data in order to find the solution. This is the response spectral shear force, showing the maximum values only. Total length is 0, at end is 2.7, total length is 3. So from here to here will be 3, and it is showing at 2.7 the value is 7.976. You can find equal, this is lateral load and this is shear moment. Okay. Let me show some table. Yes. Your fundamental natural frequency of the structure is 0.028, which is what we have seen. And for second mode, third mode, for different mode, 6 number of mode shape we are having here. For 6 number of mode shape, what are the different frequencies? And if your earthquake is going to come around 4 cycles per second in this frequency, then the first mode of displacement will be there in your structure. This is the first mode of displacement, and if earthquake matches this frequency, then resonance might occur and your deflection will be much higher. You can see that slowly it is getting higher frequency. The lowest frequency will be the dangerous frequency in case of earthquakes, and you can see the cyclic frequency here, and if you need further data you can add it. Add tables. Let us add all the tables and view here. Modal participation ratio, all the masses are being participating here. More than 90% is required as per the code. Now our structure is covering 98.7, so it is acceptable. And mass ratio, you can see that at 0.2 period of natural frequency, your structure is going to get deflected in x direction of 0.6 mm and in y direction of 0.0041 mm. At z, we have not given z factor and z displacement, hence it is not going to show any value. This is the sum, and if you add this and this, you will be getting sum of x. So you will be getting total sum at both the sides. This is rotation at x, rotation at y, and these are the modal participating mass ratio. Okay. Next, you can see moment. The moment which is acting in x direction, y direction and z. Rotation in x, y, z. Modal mass, modal stiffness. So these things are required when you are doing manually, and all the values which can be cross checked now. These things we have already seen. Yes. Now other things, center of mass. Yes. Our structure is having a mass. Let us look into this in 3D mode. Yes, this is our 3D mode. You can see the center of mass here. Now you can view the center of mass from x and y direction by center of mass and rigidity. The first floor, which is having a mass, total mass of the first floor, this is story 2. For story 2, you will be having a total mass of 14,037 kg, and first floor which is having 46,834 kg. Mass in x and y direction. Center of mass, from here the first center of mass is at 5 meter in x distance and y distance will be 3.6. Sorry, this is the second floor, 5 meter from here and 3.6 from y direction. the second story, which will be having the center of mass at 5.9 meter in X and nearly 6 meter at Y. So this is center of mass and center of rigidity, CR, center of rigidity. Total story force, you can find the maximum story force. Maximum story force will be at dead load, live load and super dead load into 1.5. This combination, you can see that force is 2209, which is 220 tons, which is acting on this load case. Like that, you can take for shear in X, shear in Y, what is the greatest value, you can check for the highest combination. Same way you can check the story stiffness. What is the drift? We have seen drift, but what is the maximum drift? We can see that due to earthquake load in X, you are having linear static, you are having a drift of 0.067 in X direction. Okay, like that you can keep on doing the analysis of the structure completely. This is called response spectral analysis.